All right, cool. So all right, so wait for my colleague Antoine to come back. But this video, we're gonna go over the differences in multi-layer switch. In a multi-layer switch, as it performs layer 2, layer 3 functions. So we're gonna go over a few things. I'm not gonna spoil it for y'all. Make it real quick. And there we go. And I think Antoine stepped away for a second. So let's give him a few.
My fault, David. My fault. Hold on.
No, Antoine, you good. You good. Take your time, man. I'm recording because I figured somebody's gonna ask you a question, ask your same question about difference between multi-layer switch.
Okay. Yeah, it's not a problem. Oh yeah, so the name of the application is Terra Team. It's pretty much it's similar to Putty, where it allows you to use the command line when you console into the device, the appliance. So I've been trying to crack it. So when I unplug it, all right. So when I plug it and boot it, right. So when it boots, I'm literally pressing M. I'm almost mashing M. And all I see is M's coming across the screen, and then it just goes to log in with the device name. I'm like, oh, come on, man.
All right. I mean, let's shoot. You know what? We could after we done, we can after we finish going over this, we can go ahead and we'll troubleshoot it, because at least you tried to research. You did the engineer thing. You researched first, try to do everything. So we'll go over it after this.
They've been telling me, once you log in, I can't log in. And of course you're not gonna say it on the Palo Alto site. So they ain't gonna give that nugget. They should though.
In the administrative, I mean, we'll dig in. There's always a way, bro. There's always a way.
Yeah.
Like I know for FortiGate, right? Certain models of FortiGate, dog. Like I was to reset it, I had to get had to get a pin, like a paper clip, put a pin in to reset it while it was booting up. So, and again, this is certain models. You know what I'm saying? Not all FortiGates, but So that's why I'm like, bro, we could find it. There's a way. There's no way they would just push out a product without a passive recovery option.
That's right.
So we're gonna figure it out. All right, let's go over this. All right, cool. Right? Got ports, right? So this is we're confident into our multi-layer switch 1 in our topology. So I'm not gonna turn in nothing else. I'm not gonna turn on no other device. It's just going over multi-layer switching, right?
Okay.
So first let's look at the config. Show run. Oopsies. Show run. What I got going on? Traceback. Whenever you see traceback, traceback on, and this is an old Cisco switch image. That means it's either about to crash, which it just did, or it's having some error. So, but again, old switches. This is an old image. This is running like 15.2. So
that's the old OS.
Yeah, that's the old OS. Yeah, that's just iOS. iOS in general. Now most of their deployments, like the Cat 9Ks, like what X was talking about, they're running now iOS XE, which is basically Cisco mimicked like other vendors and where, as far as hopefully I'm saying it right, the actual iOS, the different processes sits within a kernel, and so if one process dies, the whole switch won't die. You know what I'm saying? Rather than shoot, if multiple, if one process within the switch dies, the whole switch will stop working. So yeah. So and me learning about Juniper now, it's dog. They got it split up like that, and they've been had it split up like that for a minute. As far as different processes, while it's running on top of that kernel. But I think Cisco just adopted it not too long ago.
Mm. How is Juniper compared to Cisco? Because that's like one of the names that I heard in terms of devices that eventually gonna come across.
Honest opinion?
Mm-hmm.
Dude, that thing confusing, bro.
Juniper?
It's annoying. Yeah, it's confusing. But I'm excited for the journey. It's just, dude, it's like, come on, man. Like, why is it confusing? It's just a new platform I gotta learn, dog. But it's
right.
I mean, let me tell you this: you learning Palo Alto, their framework of how their command line is, same as Juniper, bro.
I realize, okay, because never mind. Okay.
No, go ahead. Go ahead.
No. What I was gonna say was, I was gonna say something else, but then I realized I was confusing two different things. What happened was I was expounding on I mimicked the same setup that we was working on Saturday. And what I also did was kind of like built on top of it. So
nice.
I added a firewall, and I added the router, and I added a cable modem, and on top of that, I finally figured out how the physical topology work in Packet Tracer, which was kind of awesome to me. So now I got all that is in the wiring closet in building one, quote unquote. So now I got my multi-layer switch. I got my multi-layer switch, which is pretty much my main distro switch.
Okay.
The 4 switch.
Okay.
Well, the 4 switch is connected to the multi-layer switch, which is the main distro switch. Pardon me, the 4 access switches, which is connected to the one main distro switch, which is connected to the router, which is connected to which is connected to the firewall, which hold on. I always confuse myself. One moment.
No, you good.
I gotta double check this thing. Hold up. Here we go. I was right the first time. Yeah, which is connected to the router.
Yeah, you were. Yeah,
to the firewall.
I was like, yeah, you on the right track. Track.
Which is connected to the firewall, which is connected to the router, which I have connected to the modem. Cable modem.
Good stuff.
Yeah. So I'm at to ask you, because what happened was, all right, so this is what so Packet Tracer was yelling at me. In particular, let me go back and look at this real quick.
Let me go ahead and if you got it on.
I got it up. Give me a second here. Let me go ahead and get home. Just make sure everything is great. Yeah. All right, hold on. Yeah. All right. So here we go. Share screen and Packet Tracer. And share. Boom. All right. Can you see my screen? Hey, David.
Oh yeah. Ooh, yes.
All right. So all right. So this is where I got to so far, right? So yeah. So
looking good, man. Okay, you got an ASA. Okay.
All right.
Nice.
Yeah.
Nice.
This is a little like, you know what I'm saying. I'm trying, man. I'm not trying. Pardon me. I have to get that out my. I get out my vocab. I'm doing it.
There you go.
Doing it.
Good stuff, brother.
All right. So now, if you look here, right, At first I was trying to make the port that is connecting to this thing stays up. There you go. So first I was trying to make the port that's connecting to the router which go .14, but it was screaming at me, telling me no,
Okay.
no, and telling me that you got 1.2. Why are you doing this?
Okay.
Why?
Good
Why?
stuff.
Why?
As far as
Why?
so when we mean, so when you were, just to be clear, when you configuring it on the interface, it was telling you had an overlap?
Yes.
Good stuff. Okay.
Now, I did. Now that was, I mean, I didn't understand why it was telling me it was an overlap, only because that if the port, pardon me, if the interface on the firewall, I'm thinking that, okay, it can be on the same network if it's it could be on the same network. It could be on the same network, but I guess not. But I wasn't sure why. I don't know why. Because if I have a firewall port, if I have a firewall port that's connected to the router, doesn't matter if it's on the same network, or does it matter if it's on the same network? That makes any sense, the question.
That does. This is a good discovery. So what'd you do next?
Well, I changed it. So what I did was I connected the router to an interface which I configured. Excuse me, I connected the router to an interface where I assigned an IP from a different network. So the gateway, so I made that, initially I made that network, I made that network, that port, the gateway to that network, So the port that's connected to the router, I made that port the gateway. So it would be .0.1, which is connected to .1.1. So that's what I wound up doing. And then the port and then the interface that's connected to the multi-layer switch is 192.168.1.2. But I didn't really label everything out just yet. But my confusion lies why I had to go ahead and configure the interface on the firewall connecting to the router on two different networks, ultimately. Not on two different networks, but why I had to configure the interface on the firewall that's connected to the interface on the router.
That's correct.
On a different network.
Because those interfaces are running as layer 3 interfaces, correct? And this is going to segue into what we talk about when we get to multi-layer switching, okay? A multi-layer switch. So we're gonna touch on that, but that's a good discovery, most definitely. Definitely good discovery. Let me do good stuff. Let me go ahead and start sharing so we can jump into this. Hold on.
I'll write that down.
Yeah, no doubt.
Yeah, write that down. Hold on.
Let me Twan, I'm gonna go ahead and start sharing.
No, yeah, do your thing.
Let me know when you're ready. I know you writing down something. There we go.
Okay.
Okay, cool. All right. So Twan, what I wanted to do, just based on your question, I wanted to, of course, build out a switch that has those that has both layer 2 and layer 3 functionality. But first I wanted to show you the default configuration straight out of the box of a switch, and even modern switches, even though this is a modern switch image, this is how most switches work. Typically what I've seen with Cisco and other switches. Out of the box with Cisco, right?
Mm-hmm.
The switch is going to be straight up layer 2. Have a default VLAN, VLAN 1, and just doing layer 2 switching, right? Because that's one of the 3 primary functions of a switch is the forward frames, right?
Right.
And so if we're looking at the config, right?
Mm-hmm.
You don't see anything that says, and this is the running config, you don't see anything that says anything about IP routing, right?
Right.
You see some layer 2 stuff about spanning tree, so that's there. That's a part of the 3 functions of a switch. See that, all that's configured, but you don't see IP routing configured, right? But you can configure it, right? And this is one thing I wanted to show you. So, of course, whenever we want to configure anything on the switch or any Cisco device or any network device in general, what I've learned is that you got to go to global configuration mode or configuration mode. So I hop into configuration mode, and as you can see, right, I put IP, and then I went down to routing. And what that tells you is you put in this command to enable IP routing. You see what I mean? Okay. And so here's what this does, right? And what this does, either if you're going to have a SVI, a software virtual instance, a switch virtual instance of an IP address, assign an IP address to a VLAN, or a switch VLAN interface. There's a whole bunch of names for it. The correct term, you can correct me on that term once you find it. I'll find it too. Now it's messing with me. Or you can assign an IP address to the actual interface itself and switch the actual port on the switch to an actual layer 3 interface, similar to what you did on the ASA, assigning an IP address to strictly the interface. And that's what you could do on a multi-layer switch. So you can either have a virtual interface, or you can have a physical interface assigned with an IP address.
What do you mean a virtual interface?
So you want to do a virtual interface first?
No, yeah, cause I want to see what you're talking about in terms of like a virtual interface.
No, I got you. So first, let's take a look at see what's configured so far. Show IP interface brief. All right, cool. So no virtual interface just yet. First, let's go ahead and create a VLAN. VLAN 10, name, Power Rangers. Okay. Exit. And now, whenever we want to configure a SVI, right, we're going to put interface, VLAN, and the number of the VLAN. All right. And so, and you see how it says line protocol or interface VLAN 10 changed up. So now, if I go ahead and do another, show IP interface brief. Now we should see it in that list. See it? Perfect. So now let's go ahead.
So what did you typing interface VLAN 10 do exactly?
It created that SVI. So it created that switch virtual interface.
Oh, that's right? What an SVI is.
So, yeah. So doing VLAN 10 or VLAN and then the number of VLAN that you want, that creates the layer 2 instance of a virtual local area network. Just at layer 2. If I wanted to do layer 3 within that VLAN, then I need to create a layer 3 interface.
So you could,
So which would,
I see what you just did. Okay, so let me get this straight. So when you typed in interface VLAN 10, because you created a VLAN, right? So instead of you assigning a port to that VLAN, instead you created a virtual switch, which would be that VLAN.
exactly. That makes sense? That makes sense?
I'm going to ask you another question. Because now just
Go
now
ahead.
my wheels are spinning. Okay.
Yeah, no, go ahead.
All right. So let's just say you create a whole bunch of you create VLANs. Let's just say the VLANs that we had for our project, right?
Okay, right.
Could you create a VLAN that, let me backtrack again to get the wording right. Could you create?
And don't worry, bro. Don't worry about
wording.
What wording is correct.
Okay.
I need you to just get the concept. So don't worry about getting the correct terms. We'll get that later.
Okay. So could you create a VLAN and ultimately use that VLAN to create a virtual interface that could be used for trunking? On a layer 3 switch?
That's a good question. Hold on. Let me process that a little bit. Can I create a layer 2 VLAN and a layer 3 interface that's used for trunking?
Because because I ultimately, from what I know, you have to assign an interface to become a trunking port on the switch.
Okay.
Right. So my question is not even okay. So now my question is, forget the VLAN. Could you create on the switch and a virtual interface that will be designated as a trunking port for VLANs?
Say it again. Say that question again. I'm trying to understand. My bad, dog.
No, it's okay. It's okay. It's okay. All right. So on a layer 2, or switches, I think in switches in general.
Switch in general. Yeah, switch in general. Yeah. Yep, in general. We can say that.
In general, for a VLAN to communicate to another switch, there has to be a port designated as a trunking port, not an access port. So that way VLANs communicate. So that way VLANs can communicate to other VLANs that is set up the same way on another switch in another LAN.
Exactly.
My question is, since you introduced to me the concept of creating a virtual port, a virtual interface, can you create a virtual interface and designate that interface as a trunking port?
The physical interface.
No, the virtual.
As a trunk port? The virtual interface as a trunking port?
Yes.
Okay, good question. Now, this is a good question. So let's break this down here, right? So a trunk port, right? A trunk port, access port, right? That has to do with layer 2, right?
Correct.
So, any trunking technology, what have you, that's at layer 2. Let's ask ourselves the question as engineers: how would it be possible for a switch that establishes a layer 2 trunk that has and we assign it a layer 3 interface? It's either, and this is the thing with the multi-layer switch, it's either that interface is going to be doing either layer 2 or layer 3. Can't be both. Can't be both. So, right? So what we can do, right? What we can do is, right? And let's talk about how data passes through a network. It first is going to hit, when we're passing down data, first is going to hit layer 3, then it's going to hit layer 2. So first, our switches for that specific VLAN, we create a virtual interface for. It'll have that IP address, right? It'll have that IP address for that VLAN. Let's say it wants to talk to another switch that has that same VLAN that's established a trunk between each other to pass data between multiple VLANs. That other switch can have another SVI in that same subnet for that VLAN. In that traffic, right? Once it goes down to layer 3, what's the next layer down before it gets down to layer 1? After layer 3, layer 2, right? Right? Layer 2, which operates at layer 2, VLANs.
Right.
So if multi-layer switch 1 wants to send traffic to VLAN 10 on multi-layer switch 2, right? And let's say it's connected to each other, it's going to go ahead and send that traffic. If it's a trunk between the two, it's going to send that traffic via layer 2. And then it's going to de-encapsulate and be like, oh, cool. Based on my MAC address table and my ARP table, I know where to send that. Right? But it can't be, hey, this layer 3 interface is going to be configured as a trunk. Not possible. Trunking technologies, right, is a layer 2 technology. It's not a layer 3 technology.
Okay. So let me ask you.
Let me ask you
the other. I guess. Okay, I think I understand now. So the SDI is a feature it's a feature that only exists in layer 3 for the for a multi-layer switch. So pretty much I can't create a layer 2 SDI. I can only create a layer 3 SDI.
Good question. So either I may be throwing too much terminology at you. So I think it's a little bit confused with the terminology, right? So when you create an SVI, you're creating a IP address, a layer 3 instance for that layer 2 VLAN. So when we create a VLAN, right? We create this right here. It's layer 2, right? Once we configure an IP address for it, or we create an interface for that VLAN, we created a layer 3 instance for that VLAN. So now that VLAN
I think so. Okay. Let me process this for a second.
Take your time.
Okay. So for argument's sake, I say I want phones on the .10 network, which will be VLAN 10. I would create interface VLAN 10, and then it'll create it'll create the ability for me to assign it an IP address, which I can pretty much say, okay, since I named this VLAN 10, I'll put this on the .10 network for the phones.
So you're getting there, right? No, okay. You're getting there. So in your scenario, you have phones, right? You want all your phones to communicate to the IP address of the voice VLAN. Is that correct?
Correct.
Okay, cool. All right. So yes, you can do that. You'll configure that virtual interface or the physical interface. Up to you, right? And we'll go over that in a second. But let's say you configure just the SVI, right? the switch virtual interface, right?
Right.
On the switch, not on the physical interface, to go ahead and be that gateway for that VLAN, for those endpoints that are on that voice VLAN, right? We can go ahead and do that. We can definitely configure that on the switch. Here's the thing. Here's the caveat, right? And here's the thing we have to remember. Go ahead and write it in your notes. For a layer 3 interface, an SVI, to work for a VLAN, first the layer 2 VLAN has to be configured for the layer 3 interface to work.
Wait, say it again.
I got you. So, per your question, right? You said, hey, can I go ahead and have an SVI for the voice VLAN or what have you? You can, physical and both virtual. But the thing you want to remember is, if you do not configure a layer 2 VLAN before you even configure that layer 3 interface, either physical or virtual, for that voice VLAN, traffic won't be passed, nor will the voice VLAN switch virtual interface and layer 3 interface would come up, because first you have to go ahead and create that layer 2 interface. Because think about it, right? Everything is virtual. How is traffic for a specific VLAN going to pass through a switch if it doesn't know how to get there via layer 2? So a VLAN, which operates at layer 2, has to first have a VLAN configured before it gets passed up to layer 3, which is a switch virtual interface or physical interface.
Okay, hold on.
Go ahead. And we can do it in the lab to help it make sense. You know what? While we're doing this, Twan, let's go ahead and play around with a voice VLAN.
SVI.
Name, voice. Okay. Oops. Thought I wasn't Fortinet for a second. All right.
3.
So now I'm gonna go ahead and create a SVI. Go ahead.
So you have to create a VLAN you have to create a VLAN on the switch. You have to create a VLAN on the switch in layer 2 first, before you go ahead and create a SVI in layer 3 and assign that SVI to the layer 2 VLAN.
Exactamundo.
Boom.
Make sense? Because
yes.
Look at the OSI model, right? Look at the OSI model. Your phones are going to pass traffic. It's going to pass traffic up to that switch. If we don't have that layer 2 instance there, which is that VLAN for that voice VLAN, but we only have that layer 3 instance, but we put that, we configure that SVI for VLAN, whatever, VLAN 20, the voice VLAN, but we don't have a layer 2 instance, that traffic is going to come through the default VLAN, which is the native VLAN, which is VLAN 1. And that traffic is going to be dropped. Then your end users are going to say, hey, my phones won't even register with the CUCM server. I can't make calls or nothing. You see what I mean? But if I had that layer 2 instance for VLAN 20, right?
Right.
Then the switch would go ahead, right, at the data plane, at those physical interfaces. It'll go ahead and take that traffic, de-encapsulate it, and says, oh, it has an 802.1q tag for VLAN 20. Go ahead and de-encapsulate it, send this up to the, we're going to look at all my I'm gonna look at everything that I need to look at within the packet. Oh, perfect. This is destined for the .20 network. Let's go ahead and pass it up to the SVI, which is processed by the switches CPU. It's processed, boom. Here you go, hand it off to the routing, boom. Here's how we route it. Let's re-encapsulate it, pass it on through. That makes sense?
Mm-hmm. Makes perfect sense.
There you go. That's it. That's it, man. That's it. So, I mean, it's not